The Romans did not invent everything people give them credit for. In many cases, they were masters at improving, refining, and spreading ideas that already existed. But some of the things they actually did invent, or develop into entirely new technologies, were even more impressive and far less known. So, what did the Romans actually invent? Long before printed newspapers existed, Romans could read daily public announcements known as the Acta Diurna, meaning daily acts. Introduced by Julius Caesar in 59 BC, the Acta Diurna functioned as an official public record of events taking place in Rome and continued to be published until AD 222. The notices were displayed on whitened boards, called albums, in busy public spaces, such as the Forum, where citizens could read about court cases, political decisions, military victories, public ceremonies, and even births, marriages, and deaths. After remaining on display for a period of time, the records were removed and preserved in archives for future consultation and research. Copies could also be sent across the empire to governors and officials. In many ways, the Acta Diurna acted as an early newspaper and information network, centuries before the printing press. Many texts ended with the phrase publicare e propagare, make public and propagate, announcing that the information was officially released to both Roman citizens and non-citizens. One of Rome's greatest inventions was not a building, but the material that made many of those buildings possible. Known as opus caementitium, Roman concrete combined lime, water, stone fragments, and volcanic ash known as pozzolana gathered from the region around Pozzuoli near Naples. Writing around 25 BC, the architect Vitruvius even described the ideal mixture, recommending different ratios depending on whether the structure was built on land or underwater. One remarkable property of Roman concrete was that it could harden underwater, allowing engineers to construct harbors, bridges, reservoirs, and coastal structures. One famous example is the harbor of Caesarea, where enormous quantities of volcanic ash were imported specifically for construction. After the Great Fire of Rome in AD 64, Emperor Nero's rebuilding program encouraged the widespread use of brick-faced concrete throughout the city. What makes Roman concrete particularly fascinating is that modern scientists are still studying why it survives so well. Recent research suggests that small lime fragments trapped inside the material may help repair cracks when water enters them. In marine structures, seawater can also react with volcanic minerals to form rare crystals known as tobermorite, which strengthen the concrete over time. The Romans also designed some concrete structures to better withstand earthquakes. Instead of creating completely rigid masses, builders introduced internal discontinuities that allowed portions of a structure to shift slightly during seismic activity, helping absorb stress. The Pantheon demonstrates this perfectly. Its massive dome uses heavier materials near the base and lighter materials such as pumice near the top, reducing weight while maintaining strength. Nearly 2,000 years later, it remains the largest unreinforced concrete dome ever built. Aqueducts carried water, but Roman engineers also needed ways to store it. Beginning in the early imperial period, the Romans constructed dams across North Africa, the Near East, and Hispania, creating reliable water supplies for cities, agriculture, industry, and mining operations. Spain alone once contained more than 70 Roman dams. The most common types were earth-filled embankment dams and masonry gravity dams, used for irrigation, flood control, river diversion, and water storage. What made Roman dams particularly impressive was the scale on which they were planned and organized. Large reservoirs allowed cities to maintain a steady water supply even during dry seasons, something that few ancient societies achieved successfully. The impermeability of these structures was improved through the use of hydraulic mortar and Roman concrete, allowing larger and more durable dams to be built. One famous example is the Proserpina Dam near modern Mérida in Spain, constructed nearly 2,000 years ago. and still in use today. Beneath the streets of Rome ran one of the most ambitious sanitation systems of the ancient world. Its centerpiece was the Cloaca Maxima, originally built around the 6th century BC to drain marshland surrounding the future Roman Forum. Over time, it expanded into a vast underground network connecting streets, public latrines, baths, fountains, and private homes. The system worked alongside Rome's aqueducts, which supplied enormous quantities of water to the city. After being used for drinking, bathing, and other purposes, the water flowed through sewers and helped flush waste out of the city. Ancient writers were astonished by its scale. The Greek geographer Strabo wrote that some sections were large enough for wagons loaded with hay to pass through. Public latrines were connected directly to running water channels, while wastewater from the baths could also be reused to help flush the system. For a city that may have exceeded 1 million inhabitants, this infrastructure was essential. Pliny the Elder even described Rome's sewers as one of the most remarkable achievements of Roman engineering. The Romans may also have developed one of history's earliest mechanical distance counters. According to the architect Vitruvius, the device was attached to a vehicle and connected to its wheels through a system of gears. Every 400 wheel rotations, approximately 1 Roman mile, a pebble would be released into a container. By counting the pebbles at the end of a journey, travelers could determine the total distance traveled. Some historians believe similar devices may have already been used by the surveyors who accompanied Alexander the Great centuries earlier. The accuracy of their recorded distances is remarkable. Several measurements differ from modern calculations by less than 1%, suggesting the use of sophisticated measuring methods. Although no complete Roman odometer survives today, modern reconstructions based on Vitruvius's description have successfully demonstrated that the device could have worked exactly as described. Glass existed long before Rome, but glass blowing transformed the industry completely. The technique emerged in the Eastern Mediterranean and spread rapidly throughout the Roman Empire during the 1st century BC and 1st century AD. Using a hollow tube, craftsmen could gather molten glass and inflate it into containers of almost any shape, allowing glass objects to be produced faster and more cheaply than ever before. Roman workshops manufactured perfume bottles, drinking vessels, lamps, storage containers, and even some of the earliest known window glass. The technology spread from the Levant to Italy, Gaul, the Rhineland, and beyond, turning what had once been a luxury material into something increasingly common in everyday life. The Romans were among the first civilizations to exploit water power on a large scale. Water wheels could grind grain, crush ore, cut stone, and perform many tasks that would otherwise require large amounts of human labor. Archaeological discoveries show that water mills became widespread across the Roman Empire as early as the 1st century AD, much earlier than historians once believed. One of the most impressive examples was the mill complex at Barbegal in southern France. There, multiple water wheels operated together in a cascading system capable of producing enormous quantities of flour. Some historians have described Barbegal as one of the earliest industrial production facilities in history. Roman mining was sometimes so powerful that it reshaped entire landscapes. To extract gold, engineers constructed aqueducts and channels that carried water from distant mountains into reservoirs positioned above mining sites. When released, the water blasted away soil and rock, exposing valuable ore deposits beneath. This technique, known as hydraulic mining or hushing, was used on a massive scale at sites such as Las Medullas in Spain, where entire hillsides were transformed by Roman engineering. The Romans also used a technique called fire setting, heating rock with intense fires before rapidly cooling it with water, causing it to crack apart. Combined with water-powered crushing systems, these methods allowed the extraction of enormous quantities of precious metals centuries before modern mining machinery existed. Fast speech has always been difficult to record. In the 1st century BC, Cicero's secretary, Tiro, developed a solution. He created a shorthand writing system, known today as Tironian notes, consisting of thousands of symbols representing words, sounds, grammatical endings, and common phrases. The system originally contained around 4,000 signs, but later expanded to roughly 5,000 during the Roman period, and eventually to more than 13,000 signs during the Middle Ages. Tironian notes allowed scribes to record speeches, debates, and legal proceedings much more quickly than ordinary writing. The system became so successful that it survived for over 1,000 years after the fall of Rome and is often considered one of the earliest forms of stenography in history. And these were some of the inventions and technologies developed by the Romans. While roads, aqueducts, and amphitheatres often receive most of the attention, innovations like the Acta Diurna, Roman concrete, hydraulic mining, Tironian notes, or the odometer reveal just how advanced Roman engineering and administration really were. But Rome was only one civilization. In the next episode, we'll explore what another ancient civilization actually invented. If you'd like to follow the series, consider subscribing so you don't miss future episodes. Until then, thanks for watching.